Hi all and welcome to a new video on Solidity development. Today we're going to cover a super interesting topic called mappings. So we're going to begin as always by looking what exactly is a mapping. Now mapping is a very fundamental concept in Solidity development, and it's important to understand as we'll be using them quite a lot going forward. So mappings can be thought of as a great way to store key value pairs in Solidity. They're the equivalent of dictionaries or hash tables in other languages, and they're quite common in Solidity. So why do we use mappings? Mappings are great for associations and tying two pieces of related information together. So for example, a good use case of a mapping would be is if we had a given number of users, and we also need to associate a balance with each of these users. So we could create a mapping for these user balances, and we could have each individual user's addresses, and we could associate that with a uint which would represent a user's balance. Similarly, if we had a game, we could associate every single user's address with another uint which could represent their score. So they might be level 1, level 2, level 3. So without further ado, we're going to jump into the code, and that should help solidify exactly what is going on with mappings. Hi all and welcome back to the video. Here we can see we're in the Remix online IDE. If you haven't used Remix before, it's essentially a great little tool for practicing your Solidity development, and it's a completely free IDE where you can deploy contracts into a virtual machine, or else you can actually deploy onto a test network. So jumping back into the code about mappings, we've created a blank shell for a contract here, and we called it message. So we're going to begin by actually defining the contract. So we begin by using the mapping keyword, and then we define what type of variable we want to use for our key. So in this case, we're going to use a uint, and we're going to define what type of variable we want to use for our actual value. So in this case, we're going to use a string. We're going to declare this as public, so anyone can view this mapping, and we're going to give the mapping a name. So for this example, we're going to use names. Then use a semicolon to finish out, and that is essentially it. Our mapping is defined, and it accepts a uint as its key and has its value as a string. So we're going to initialize this particular mapping with some values. For this, we're going to use a constructor function. So a constructor function is essentially just a function that can only be run once when a contract is created. And we're going to use this constructor function to initialize our names mapping with some values. So we begin by using the names, and then we pass in the given key we want. So for this instance, we're passing in 1 into the square brackets, and we're going to give a name of John. So this can be any name you want, and we're going to finish the line with a semicolon. And we're also going to create another entry for this mapping, and we're going to have the ID set to 2, and the name shall be Philip. So that's pretty much two initial values defined for our names mapping. So if we save this contract and we deploy it, we can see it's successfully deployed, and we have our names mapping available here. So if we pass in 1, we get John. If we pass in 2, we get Philip. And what happens if we actually pass in an ID that we haven't defined? So if we pass in something like 99, we just get the default value, which is... Okay, now we're going to discuss another super cool use case for mappings. So that is mappings with structs. Now a struct is a special type of data structure in Solidity which allows us to create our own custom data structures. So for example, if we use the keyword struct and we define a struct name such as a person, we can then define what characteristics we want this hypothetical person to have. So these can be a number of different data types, but for this example, we're going to use a string and we'll say first name, and we're going to semicolon, and finally we'll use a uint and we'll call it person age. It's just to show that we can have different data types. And we can actually create our own mappings, which has its own ID as the key, and then the value is actually this person object. So we do this in the same way. So we define what type of variable we want for our key. So in this case, we want uint, we use our arrow, and we are going to use the person struct that we just created. And similarly to, we're going to define this as a public mapping, and we're going to call this mapping people. And we're actually going to create a function so to actually add people as opposed to using the constructor function. So we're going to say add person as our function name, and we're going to define the input. So for this, we're going to have a uint for our ID. We're going to have a string. We're going to save this in memory for our first name. And we're going to have a uint for our age. And this is going to be a public function. And we're going to have this function add a person to our custom mapping up here, which we made. So it's going to reference people. And then we're going to put this for our underscore ID for our key. And we're going to initiate a new person struct, passing in our two variables here, which is our first name and our age. Now if we compile this contract, okay, it seems we have an issue, and that should be fine. We're going to compile our contract. We're now going to deploy it to the virtual machine. And as we can see, we have our function and we have our new mapping, which has our struct functionality embedded in it. So for this, if we add a person, we give him the name of John, and we give him an age of 18. We can now successfully add the person, and if we put in our ID, we can actually retrieve this data. So as you can see, we can, first name is John and our age is 18. And that pretty much rounds up our video on mappings. Hope this was useful. If so, please smash the like button, as it really helps me out. And until the next time, thank you very much.